Welcome to Simply Understood. Let's talk about descriptive statistics versus inferential statistics. Generally speaking, statistics can be divided into two main categories: descriptive statistics and inferential statistics. Basically, descriptive statistics describes data and inferential statistics infers from data. To be more specific, descriptive statistics are used to summarize and describe the main features of a data set, while inferential statistics are used to make predictions or draw conclusions about a larger population based on a sample of data. We use descriptive statistics when we want to analyze data from a sample or population without making predictions or generalizations beyond that data. In contrast, inferential statistics allows us to go beyond the collected data and make broader conclusions or predictions. Before continuing, it's important to understand the difference between a population and a sample. A population is the entire group being studied, e.g., all students in a university, whereas a sample is a subset of the population used to draw conclusions and make inferences, e.g., all the students enrolled in a statistics class. Samples are easier to work with since it's not always practical to collect data from an entire population. It's also important to know the difference between a statistic and a parameter. When a measurement is used to describe a sample, it is known as a statistic. But when it's used to describe a population, it is known as a parameter. Here's an easy way to remember this. Statistics measure samples and they both start with S, while parameters measure populations and they both start with P. So what are some examples of descriptive statistics? One example is measures of central tendency, which tell you where most of the numbers in a data set tend to cluster. These include the mean or the average, determined by adding all the numbers and dividing by how many they are. The median, which is the middle value when all the numbers are in order, and the mode, which is the number that appears the most often. Other examples of descriptive statistics include measures of dispersion, like range, which tells you how spread out a set of numbers is by measuring the distance between the smallest and the largest number. Variance, which tells you how spread out the numbers are in a data set by measuring how far each number is from the mean. And standard deviation, which is just the square root of the variance. Finally, data visualization tools like histograms and box plots also help us summarize and describe data by showing us how the data is distributed visually. Now, some examples of inferential statistics include estimations like confidence intervals, which provides the degree of uncertainty or certainty in a sampling method. Hypothesis testing, which is used to determine if there's enough evidence in a sample of data to infer that a certain condition is true for the entire population. And some other common tests, such as z-tests or t-tests, which are used to determine if there is a statistically significant difference between sample and population means, or between means of two samples. Lastly, it's important to remember that descriptive statistics can be used with both samples and populations, whereas inferential statistics specifically relies on sample data to make predictions or draw conclusions about a population. For instance, the mean, which is a descriptive statistic, can refer to either a sample mean or a population mean. In contrast, hypothesis testing, An inferential statistic is used to figure out if there is enough evidence in a sample of data to infer that a certain condition holds true for the entire population. Okay, that's going to do it for descriptive statistics versus inferential statistics. Hopefully you enjoyed this video, and if you did, please consider liking and subscribing. With that being said, thank you for watching and have a great day.